Hi there. In this presentation, going to share a few key results that we achieved in our offline transcription module, which is a parallelized one. And we might have discussed few of the things already in the previous demos related to challenges and how we overcame those issues. So I think I'll jump right into the results. So as a starting point, the red line that you see here is the previous state of the art accuracy that was achieved at Affinity, and from there onwards this point that you see here is the Whisper medium model. So on the x-axis that you are able to see all the models that are listed, and on the y-axis is the accuracy or the word error rates. So previously the best performing models that was experimented at Affinity was Whisper Large, which gave a word error rate of about 20%, and our Whisper medium model, which is a parallelized one as well, is about gives about 11% word error rate here. And moving forward, we measured the execution times of the transcriptions performed of the combined length of 15 minutes. And just to note that we uploaded the audio first to the Google bucket first, which is as close the data can get to the Google sort of server that will transcribe that. And after uploading it to the bucket, when we transcribed it, it took about 5 minutes. And when we compare to the model that is running locally, for example Tiny English model, it took about 1 minute to do the same job. Here are the error rates that we have listed. The so just heads up here that the data that we tested all of these models on were the most complex samples that we could find. That means they were mono, they were noisy, they had speech overlap, 8000 hertz per second sampling rate, and there was significant speech overlap in there, and there was essentially background noise, all of that. So we incrementally started testing from simpler ones to the most complex ones, and these results that you see here are for the most complex audios that we could find. So the Google STT model that is listed here, just to note that this is a specialized model which is called phone call model, specifically trained for transcribing phone calls. So this is not some generic model, gave us about 60% accuracy, whereas locally running models from tiny to large, the largest one giving us 88.2% accuracy. The results that you see here, just to give you an idea, like at the x-axis you can see from 1 to 40, which is the number of files that we transcribed in parallel, and we logged the memory consumption of the V100 GPU, which has 32 GB of capacity, and some of that gets reserved by the running environment, Python, PyTorch, system-based GPU requirements, and what we essentially get is 17 or 18% usable GPU memory. And if we look at the last point here, which says 40 on the x-axis, and we see the top line which represents medium English model, it took about 17 GB of VRAM from the GPU, and it was able to transcribe 40 calls at max in parallel. At the same time, if you see at the lowest line, which represents the Tiny English model, it transcribed 40 minutes audios 40 audio files in parallel by using about 6 GB of memory. So the smaller model takes smaller amount of VRAM. And on the right graph you are able to see, so the top line presents medium English model, and what this essentially says is the medium model took about 8 minutes or so to transcribe 40 calls, and the lowest line, sort of like purple or violet, shows the Tiny English model took about 6 minutes to transcribe 40 calls in parallel. Moving on to the next graph. Here what we have done on the x-axis is we have took the combined length of the audio in minutes. So what this means is that if you look at the top line, which is Whisper Medium model, this says that the Whisper Medium model transcribed 200 minutes using 17 GB of RAM, and on the right it shows that it took 8 minutes to do that. And let's look at the bottommost line on the left side. This says that the tiny English model took about 6 GB of RAM to transcribe 200 minutes, and on the right the bottom line represents the same tiny model did the same in about 6 minutes. Here are the key results that I have listed here, and just to reiterate on the accuracy, I just want to make clear that I have actually shared the audio files, the output from all of these models, and the actual ground truth transcriptions in the product work streams, just so that if anyone wants to verify, they can verify on these results. Again, to reiterate, the Google model was specifically designed to transcribe phone calls, which is called phone call model, and all of the testing that was performed was on the most complex samples that we could find. Same like it had speech overlap, static noise, and background noise, all those things. So Google model was 57% accurate, but I think the most interesting part here is that let's the base model was 77% accurate. It consumed 7.51 GB of RAM. It transcribed 200 minutes, or let's say 3.6 hours, in 5.8 minutes, and the maximum parallel audio files that it can transcribe in one go is 80 files. And the same can be seen at the last line where media model gave us 86% accuracy. So just there is some confusion here because actually this no, I think that's correct. Okay. For the model sizes, the medium takes about 1.45 GB, the smaller one takes less than 1.4, and that's why you are able to see that they are faster because less parameters to work with during the forward pass and inferencing, and that's why they are able to handle more calls in parallel. And this is just some charges that I can list here, like they charge $24 to transcribe 1000 minutes, but I think GTA have worked more extensively on that, and so they can give more accurate costing. This is just what the Google console was showing to me. And yeah, that's it for this presentation. Thank you so much.